Hello friends, I often get asked, how do you calculate melt density for a given material, for a given mold that you're running in the shop? How do you calculate melt density? Because a lot of times they need it for certain calculations, especially if you want to move the mold from one machine to another machine. And now you want to calculate the shot size for the new machine. And for several other reasons, even maybe they're going to quote a new part on that same material, and they now need to find out what's the right machine for it, etc. So there are several reasons why one would need the melt density. So actually the answer is very simple. Typically what people do, they will go to the PVT diagram, they will go to the material supplier, they'll go onto a website and look at the PVT diagram and say, okay, this is the volume at a certain temperature, process temperature, and this is probably the pressure that we're going to use, and so this is the melt density that we will use. There's also other things that they say that you can use a factor of 0.7, 0.8, etc., and multiply the solid density number with that number with 0.8 or 0.7, and now you can get the melt density. But I'm going to show you a really simple way to calculate the melt density. Okay. So let us say that you're molding a part in your shop and the shot weight is 63.17 grams. The screw diameter is 35 millimeters for this particular machine. The shot size you have set on the molding machine is 104.6 millimeters, and the cushion value that you currently have is 6.6 millimeters, right? So now what do we need to calculate? We want to calculate the melt density. Yeah. So the formula for weight is equal to volume times density, right? And therefore density is equal to the weight divided by the volume. So if you see the weight, we already have the weight, right? It is equal to 63.17 grams. And now we need to find out what the volume is, right? So if you see what the volume is equal to the volume of injection. That means you're going from the shot size to the transfer position to the cushion value. So we're going to eliminate the transfer position. We don't need the transfer position anymore. So we're going to go from the shot size to the cushion value. And so if you see that value is 104.6 minus 6.6, and that is equal to 98 millimeters. Okay, so the travel distance of the screw is 98 millimeters, and therefore now you know the travel distance is 98 and your screw diameter is how much? 35 millimeters. And so based on this, on the formula for volume is equal to 0.785 multiplied by D multiplied by multiplied by 98, right, which is a length, that is pi d square multiplied by the length, and therefore it's 0.7. So where did I get 0.785 from? It's 3.14 divided by 4, right? So I just keep it simple at 0.785. 785 multiplied by 35 multiplied by 35. If you do this calculation, your total volume turns out to be, I've written an article on Plastics Technology magazine, so I'm going to put a link, you guys can check that out. The total injected volume comes out to be 94.28 cubic centimeters. Okay, so note that it's all in millimeters. We also convert into centimeters. So what happens? Your total volume is 94.28 centimeter cube, right? That's it, right? So now if you calculate, going back to this formula here, right, the density, I'm going to calculate here, and therefore the density is equal to weight 63.17 divided by 94.28, which is a volume, and therefore your density turns out to be 0.67 grams per centimeter cube. Right? A very simple formula example out here I'm giving you. Now this is the actual melt density, because this is what we are injecting inside the mold, right? So this is what is the actual melt density. So if you do the calculation, this is an HDPE material. So the HDPE material, I just changed colors here so that it's a little bit more not crowded as much. Sorry, I'm just doing this on the fly, so it's not a nicely edited video. So if you see this, the density of HDPE is 0.95, and now this is solid, and the density of the melt is 0.67, right? And if you look at this, this is basically a factor of, I have a calculator right here, so the factor of 0.67 divided by 0.95, that's factor of actually it's a factor of 0.7, so that's a good estimation. Okay, so it comes out to be factor is 0.705, right? So the numbers that we use generally 0.7, 0.8, they're good numbers, yeah. But if you want to really calculate what the melt density is, here's a very quick way that you can calculate it, right? I have written an article on Plastics Technology Magazine that I'm going to put a link that you guys can check it out also, right? Thank you, all the best, and keep molding. Thank you, bye.